Section 10.2, functional groups. Now this will be where we have organic compounds with other atoms besides hydrogen bonded to the carbon chain. And what you're looking at here are quite a few of the various functional groups that we'll be talking about. We'll not hit all of these, but many of them. A functional group is an atom or a group of atoms that give organic compounds specific chemical properties. Now I'm going to show you a short video, it's just a couple of minutes long, that's a nice preview on the notes that you're about to take. So don't take notes on it, just watch.
This is MSJ Chem. In this video, I'll be looking at functional groups. Let's start with the definition of a functional group. A functional group is a group of atoms within a molecule that are responsible for the characteristic chemical reactions of the molecule. Compounds that have the same functional group can be divided into classes. Here we have a 5-carbon alcohol, which is pentan 1-ol. The class is the alcohols and the functional group is the OH or the hydroxyl group. Next, we'll look at all the classes and functional groups that you need to know for standard level chemistry. So the first example is the alkanes, which have carbon-to-carbon single bonds. An example is ethane. Next, we have the alkenes, which have carbon-to-carbon double bonds. An example is propene. Next, we have the alkynes, which have a carbon-to-carbon triple bond. An example is ethyne. Next, we have the alcohols. The functional group is called the hydroxyl group. An example is methanol. The carboxylic acids have a carboxyl group. An example is propanoic acid. The aldehydes and the ketones both have a carbon double bonded to an oxygen, which is a carbonyl group. In the aldehydes, the carbonyl group is bonded to one other alkyl group. In the ketones, it's bonded to 2 alkyl groups. An example of an aldehyde is ethanol. An example of a ketone is butanone. Next, we have the esters. This is the ester functional group. An example is ethyl ethanoate. Next, we have the ethers. This is the ether functional group. An example is methoxymethane. Next, we have the nitriles. The nitriles have a carbon to nitrogen triple bond. An example is butane nitrile. And finally, we have the halogenoalkanes. The functional group is halogeno. An example is chloroethane. The next example are the arenes, which have the phenyl functional group. An example is phenol. Moving on to the amines, this is the amine functional group. An example is ethanamine. And our last example are the amides. This is the carboxamide functional group. An example is propanamide.
Functional group classifications. Now there's going to be 14 classifications where you're going to be given the structure, what makes it a functional group, what the structure is, and how we go about naming it. So that's kind of our ultimate goal here, is to be able to identify the functional group, draw it, and name it. Now the first 3 you're already familiar with. It's alkanes, alkenes, and alkynes, which are, in fact, functional groups. So I'm going to go through these pretty quickly, the first 3. An alkane functional group is the alkyl, and that means simply that it's nothing but hydrocarbons with single bonds. It's called an alkyl group, or the functional group. So that would be butane. It's a butane lighter. An alkene has the alkenyl functional group, which refers to the double bond between 2 carbons. The name of this would be but1-ene. Now, I'm going to be giving you the IUPAC name, the IUPAC name that you're responsible for, but I'm also going to give you, for many of these, another common name that is much in use, but you're responsible only for the first name that I give you. So 1-butene, it's also known as. And then an alkyne functional group, alkenyl. Example, and the alkenyl refers to the triple bond between 2 carbons. That's the functional group. And the name of this is ethyne. Ethine has a common name of acetylene, and you might be familiar with welding acetylene torches. Acetylene gives off a very, very hot flame. Okay, so now something new. Halogenoalkanes. Functional group is halogens. So we're going to have one of the four halogens bonded to a carbon chain. So fluorine, chlorine, bromine, or iodine. This is fluoro, chloro, bromo, and iodo. These are the root of the names of those halogens. Example. So here we have a 3-carbon chain, and off of it we have a chlorine. So we need to have a number to tell us where the chlorine is, because the chlorine could be off the first carbon or the second carbon. One of the nice things about the systematic naming system that we're learning is that once you kind of get the hang of it, you can predict what the name would be for a compound that you've never seen before. So logic would tell you that we need a number to tell us where that chlorine is, and it's off of carbon number 1. So the name of this is 1-chloropropane. So 1 for the first carbon, chloro for being chlorine, the functional group, and it's off of a 3-carbon chain, which would be propane. Now for this one, we have 2 chlorines and a bromine. Now remember when we had methyl and ethyl as functional groups for hydrocarbons, we named those in alphabetical order. We do exactly the same thing here. We name the bromine before the, that's right, the bromine before the chlorine, because bromine is alphabetically first, even though it's off of the second carbon. And also we have 2 chlorines, so that would be dichloro. Remember that if we have identical branches, we use di, tri, or tetra to represent the number of them that we have. So the name of this would be 2-bromo and then hyphen 1,1 dichloropropane. So again, no spaces anywhere. Now I suggest as we go through these that you pause the video and just kind of look at the structure and look at the name. Hopefully the logic of the naming system will kind of click in, and it makes it much more easy. If you try to just memorize these names, it's not going to work. You need to understand the system. Now for this, we have both halogens and an alkyl group. Now to name this, we're going to name the halogens first. So bromine and then chlorine and then the methyl. So the name is 2-bromo, 1-chloro, 2-methylpropane. We always name the halogens first. Now, kind of a guiding rule when we name organic compounds is we look at what distinguishes the organic compound the most. Whatever that is, we want to highlight that at the beginning of the name. So what's more important here, what makes it a bit more unique, is that it has halogens. And so we put the halogens out front. Now again, if you look at the name going backwards, everything kind of falls into place. So propane tells us it's a 3-carbon chain. We have methyl off of carbon number 2. We have a chloro off of carbon number 1. And a bromo off of carbon number 2.
5. Alcohols. Alcohols have the functional group hydroxyl, OH. Now we don't draw the bond to the hydrogen, but it's there. So hydrogen and oxygen are covalently bonded. Example, this is the most common, well-known alcohol of all, ethanol. Now the name ends in OL, comes from alcohol. It's also known as ethyl alcohol. This is the alcohol that's found in alcoholic beverages and used as an alternative fuel. Almost all gasoline these days is about 10% ethanol. Ethanol mostly being derived from corn. Now for this compound, the hydroxyl group is off of the second carbon. So we need to have a number to indicate that. We didn't need a number for ethanol because it was only a 2-carbon chain. So it had to be off the first carbon. Either one of these would be the first carbon. But for this compound, we need a number. So the name of this is propan 2-ol or 2-propanol. Now, this has a more common name, isopropyl alcohol, which might sound familiar to you. It is rubbing alcohol. Now, you should know these 4 names for isopropyl alcohol. IB is very specific about certain things. And one of the things is that very well-known compounds you should know, you should be familiar with. You should know that the propan 2-ol is rubbing alcohol or isopropyl alcohol. You should know that ethanol is the alcohol that's in alcoholic beverages or used as an alternative fuel. Now, the fact that there's multiple names for organic compounds is a bit maddening, I know. What I did was I took a page from Wikipedia here, just to give you a sense of the commonality of these multiple names. So this is isopropyl alcohol. And if you look off to the side here, and you'll see this for all Wikipedia pages dealing with compounds, is to list all of the names. You can see for isopropyl alcohol, they give you the IUPAC name, the propan 2-ol, but they also give you a bunch of other names here. So 2-propanol, isopropyl, rubbing alcohol, and others. Now, you just have to kind of reconcile yourself to the fact that organic compounds have many different names. But of course, you're only responsible for the IUPAC name, the systematic name. A few more things about alcohols. Alcohols are capable of hydrogen bonding, resulting in higher boiling points and solubility than other compounds. So alcohols have a hydrogen bond between the molecules, which means that they have a relatively high boiling point, because remember, hydrogen bonds is the strongest of all intermolecular forces, and makes it so that alcohols are very soluble in water. Water also is capable of forming hydrogen bonds. So the big takeaway here is know that alcohols have a higher boiling point and more soluble than other organic compounds, and the reason why is because they're capable of forming hydrogen bonds. Also, alcohols are denatured by adding small amounts of toxic materials to make it unfit to drink. This is often done for safety purposes. For example, natural gas, that rotten egg smell that you smell when there's a gas leak, that is artificial. Methane has no odor. They put that scent into methane so that you can easily detect it, and it's a foul smell, so you immediately want to take care of it. Classification of alcohols. So there's 3 classifications: primary, secondary, and tertiary. Now this would be a generic representation of primary. Now let me explain the R. R is used in organic chemistry to mean any carbon chain, or more specifically, any alkyl chain. So when you see an R, just think that it's a carbon chain of indeterminate length. We don't really care about the length of it. What we care about is what is bonded to it. So in this case, for a primary alcohol, we're interested in the fact that the hydroxyl group is bonded to a carbon that is itself bonded to only one other carbon. So here's a real example. So the hydroxyl group bonded to this carbon, which is bonded to only one other carbon. So the fact that it's bonded to only one other carbon makes it primary. For secondary, the carbon is bonded to 2 other carbons that has the hydroxyl group. So this hydroxyl group bonded to this carbon, that is bonded to 2 other carbons. Tertiary, bonded to 3 other carbons. So for this example, the carbon is bonded to 3 other carbons. So be able to determine whether an alcohol is primary, secondary, or tertiary simply by looking at the number of carbons looking at the carbon that has the hydroxyl group and counting how many carbons is it bonded to. A lot of times students get kind of messed up here thinking that it's primary because it's off of the first carbon or it's off of the second carbon, but no, it has to do with the number of carbons that, it has to do with the number of carbons that the carbon that has the hydroxyl group is bonded to. I don't think I said that very succinctly, but I think you get the gist. Next, aldehydes. Aldehydes have what's called the carbonyl group, which is a double bonded oxygen. Now, for an aldehyde, that carbonyl group will always occur at the end of a carbon chain, which means that one of the other bonds that the carbon has is to hydrogen. Then this bond would go either to another hydrogen or to a carbon chain. So an example, this is a 3-carbon chain. So if this was a hydrocarbon, it would be propane, but we drop the E and we add Al. So this becomes propanol. The Al comes from it being an aldehyde. Now this is a very well-known aldehyde. So rather than the carbon being bonded to a carbon chain, it's bonded simply to another hydrogen. So this is a 1-carbon chain, so it'll be meth. So this would be methanal. Common name for methanal is formaldehyde, which for many, many years was used as a tissue preserving agent. When people would die and they would be embalmed, when their blood would be replaced by a chemical to preserve their bodies, it was formaldehyde that they usually used. It's not so much used anymore. It's pretty toxic, dangerous stuff. Now for this, we need to have a number to tell us where the methyl is. And by definition, the carbon that has the carbonyl group, the double bonded oxygen, is defined to be carbon number 1. So this would be carbon number 4 off of a 5-carbon chain. So the name of this would be 4-methylpentanal. Ketones. Ketones also have a carbonyl group, except in this case, the carbon that has the double bonded oxygen is bonded to 2 other carbons. So there's 2 other alkyl chains on both sides. So this would be the simplest example where you have a 3-carbon chain where the center carbon has a double bonded oxygen. So this is 3 carbons long, so that would be prop, and then we add the ONE ending. So this becomes propanone. So ONE. It's pronounced own, not one. So propanone. Common name is acetone, which some of you probably know is a common organic solvent. You can buy cans of it at the hardware store. It is the active ingredient in nail polish remover. Now for this compound, we would need to have a number to say where the double bonded oxygen is. We didn't need that for propanone because it was only possibility was off the center carbon. If it was on the end, well then that would be an aldehyde, but it's not. It's a ketone. But for this compound, the chain is long enough that we would need to have a number to tell where the double bonded oxygen is. It could be off the 2nd carbon or it could be off the 3rd carbon. So we need a number to tell us that. So pentan 2-one or 2-pentanone. Ethers. Functional group is also called ether. And this is a case where the carbon chain, one of the carbons, you kind of think of it like this, one of the carbons has been replaced with an oxygen. So the oxygen has a carbon chain bonded on both sides of it. So example here, you have a methyl on one side and an ethyl on the other side. Now to name this, it's a bit different than the others that you've seen where you just simply tack on an Al or an Ol or something at the end of the name. Here, we need to first identify the shortest chain, and that would be meth. And then because it's bonded to an oxygen, we add the suffix oxy. So this becomes methoxy. And then the longer chain, in this case 2 carbons long, we name it as if it was an alkane. So this would be ethane. So the name of this is methoxyethane. Okay, so in your notes, try to be clear about this. The shortest chain is what we name first, and we tack on to that oxy. And then we name the other alkyl group as if it was an alkane, the longer one. And so that would be ethane in this case. Now it's also can be named methyl ethyl ether, where each one of these is naming the alkyl group. So this would be methyl, this would be ethyl, and then it's an ether. Now it doesn't matter which order. You could say methyl ethyl ether or ethyl methyl ether. But the IUPAC name, systematic name, is methoxyethane. Okay, so for this one, we have an ethane on both sides, or an ethyl on both sides. So we name it exactly the same way. So since it's a tie, we would name one side ethoxy and the other side ethane. So it should be ethoxyethane or diethyl ether. Rather than ethyl ethyl ether, we would say diethyl ether. Now this is a very common ether by far, and it's called ether. Anytime you hear something being referred to or an ether being used for this or that, this is almost certainly the ether that they're talking about. It was one of the first anesthetics. In 1841, it became fairly well used as an anesthetic, which would knock people out for surgery, say. It's a liquid. It's a very toxic liquid, has very, very pungent odor. And so they would just put a few drops on a mask and then have the patient breathe it in, and it would knock them right out. Carboxylic acids has the functional group carboxyl. Now, carboxyl has both a double-bonded oxygen and an OH. So it's the carbonyl and the hydroxyl group, which means that the carbon only has one other bond. So like an aldehyde, it's going to occur at the end of the chain. So for example, this is a 2-carbon chain, and here's our carboxyl group. So this would be eth. Now the name, let me just show it to you. The name would be ethanoic acid. So we look at the longest chain. Look at the chain. So the carbon chain here is 2. So that's ethane, and then we add oic acid to it. So if it was just 1 carbon long, it would be methanoic acid, ethanoic acid, propanoic acid, butanoic acid, just depending upon the length of the chain. Common name is acetic acid, which you know is the active ingredient in vinegar. Now, all carboxylic acids are what we call organic acids. All organic acids contain the carboxyl group. This is something I mentioned in our unit on acids and bases, you might remember.
Next, esters. Esters have this as their functional group. It has a carbon with a double-bonded oxygen, like a carbonyl, and another oxygen that is a link in the chain, like an ether. So example. Now, in order to name this, what you want to do is to bisect the molecule. The oxygen that is a link in the chain, look at, on one side, you're going to have the carbon that has a double-bonded oxygen. On the other side, you won't. You'll simply have an alkane chain, an alkyl group. To name this, we name the side that doesn't have the double-bonded oxygen first. And in this case, it's 1 carbon long, so that's methyl. And this is 2 carbon long, so that's ethyl, but we changed the name slightly. The name will be methyl, again, naming the side that doesn't have the double-bonded oxygen first. And then there's a space, and then ethanoate. So eth, because there's 2 carbons, and then we have that OATE ending. So methyl ethanoate, 2 halves of the ester. Common name is methyl acetate. Methyl acetate. Okay. Esters are commonly used as flavoring agents. Should know that. Now, unfortunately, there's a lab that we do in IB Chem 1 where you make esters, and the esters have all kinds of nice aromas. You would have been allowed to pick a few odors, fragrances to create. So vanilla, orange, banana, wintergreen, So it's kind of cool. So you mix together a carboxylic acid and an alcohol. You heat it up, put in a catalyst of sulfuric acid, heat it for about 10-15 minutes, and it will begin to give off these fragrances. Sorry you weren't able to do that. Perhaps next year in IB Chem 2. Okay, next, an arene or aromatic. I prefer the term aromatic. The functional group is phenyl. You might recognize the benzene ring. So on the benzene ring, yeah, you have some carbon chain. So for example, for this, so you have methyl on a benzene ring. So we can name that methylbenzene. But we can also name it phenylmethane. So it's kind of like your perspective. We can look at the benzene being the methyl being attached to the benzene, or the benzene being attached to methyl, in which case it would be called phenyl. So either of these are acceptable. Common name is toluene. It comes from a tree in South America. The Greek or the Latin name for that tree, that's where that word, this substance can be extracted from. That's where the name comes from. Another example, this. Okay, now this is again a case where you likely could name it if you think about it. So pause the video here in a second and see if you can name this compound. We'll give you a couple of hints first. So we'll name it with this being the benzene ring. So benzene will be in the name, and you have 3 chlorines. We're going to want to number the ring such that we get the smallest numbers possible. Okay, so pause the video, see if you can name it. All right, so we have 3 chlorines, so it's going to be trichloro. But when we number the ring, we want to number so that we get the smallest numbers possible, which would be, this would be carbon number 1, 2, 3, 4. So that gives it 1, 2, 4 trichlorobenzene. If you were to number it in the other direction, it would be 1, 3, 4, which are higher numbers. Another example is just a well-known compound, phenol. I know it's phenol and phenol. That sounds almost identical. And this is where you have a hydroxyl group attached to a benzene ring. Amine, functional group amino. Now there are 3 different amino groups, but they all have in common the nitrogen. So nitrogen is part of your organic molecule. So here, the nitrogen is only bonded to 1 carbon. Here it's bonded to 2. Here it's bonded to 3. Remember, nitrogen will form 3 covalent bonds. Remember the Hank rule. Okay, so for example, this has a amino group on a carbon chain. It's the 2nd carbon in. So the name of it would be 2-aminopropane. We need the 2 to tell us where it's located. We can also name it 2-propane-amine or propan-2-amine, but I would go with the first one. Okay. So see if you can name this one. You have 2 aminos. So see if you can name it using the IUPAC naming system. Okay, so its name would be 1,3-diaminobutane. Another example, here you have a methyl on either side. So dimethylamine. Another example, you have 3 methyls. So I'm sure you would guess correctly, trimethylamine. And I'm sure when you heard amino, many of you thought amino acids, and you're on the right track. For an amino for a compound to be an amino acid, it has to have both the carboxyl group and the amine group. So it doesn't matter how big the molecule is, so R could be of any length, but within the molecule, if you have both of those functional groups, it's an amino acid. And if you don't know, amino acids combine to form proteins, which are the building blocks of life. Very, very important substances. Next, an amide, functional group carboxamide. And for this, it's kind of like a carboxylic acid. You have a very busy carbon. It's a double bonded oxygen, so it's a carbonyl group and an amine group. So it has only one other bond. It has to occur at the end of a chain. To name it, we simply say amide. So ethanamide, 2 carbons long, ethanamide. Okay, last is nitrile. The functional group is nitrile, and for it, you have a triple bonded carbon and nitrogen. Now remember, nitrogen can only have 3 bonds, so it's not going to have anything else bonded to it. The carbon does need another bond, so it's going to be at the very end of a chain. Okay, to name it, now this is a 2 carbons long. To name this one, it's 2 carbons, so it's ethane, and we add nitrile. So ethane, nitrile.
If it was 3 carbons long, it would be propane, nitrile, etc.
Okay, that is it, all of the functional groups. Now what you're looking at here is a handout I would be giving you were you at school. It is available on our lesson module, so please take a look at it, download it, print it out if at all possible. It gives you a nice summary of each of the functional groups that we have discussed. They give you an example, and the last column is the name for that example. So you might try, when you're reviewing, covering up the name and just going down one by one and see if you can name it. It also gives you a general formula for the name. That might be helpful. It's not something that I discussed in the notes. All right, that is it, boys and girls. End of notes.